In this video, we're going to use triple integration in cylindrical coordinates to work out the volume of this solid. So this solid is bounded above by this surface, which is this surface here, which is this paraboloid here, and within this circle of radius 2. So if it has a radius of 2, then straight up you will hit this at a height of 4. So just bear that in mind for later on. So I'm expecting you to be able to accept this by now, because we've done many videos on this. When you're working in cylindrical coordinates, you have to know this by now. And in cylindrical coordinates, when you convert from Cartesian coordinates into cylindrical coordinates, then this thing becomes this thing, and I'm expecting you to be able to accept it. And again, we've done many videos on this. So now this volume here, the volume of this solid, is given by this triple integral. So it's just a matter of us setting up the limits of integration. So so in terms of the height z, you're integrating from a height of 0, and then you stop when you get to the surface. You stop when you get to the surface. So here you're integrating from a height of 0, and then you stop when you get to the surface, which is this thing here. So x squared plus y squared. But in cylindrical coordinates, x squared plus y squared is really r squared. So you can put that into here. So really you're integrating from z equals 0 to r squared. And in terms of the radius, you're integrating from a radius of 0, and then you move along until you get to a radius of 2. So you're integrating like this. Thinking in terms of the radius, you're integrating from a radius of 0, and then you move along and then you stop when the radius gets to 2. So you're integrating it from a radius of 0 to a radius of 2. And then in terms of the angle theta, you're integrating it from theta equals 0, and then all the way around like this until you get to an angle of 2 pi. So you're integrating from 0 to 2 pi. So this volume here is given by this triple integral. So it's just a matter of us evaluating that integral. So we are now here. So let's integrate it. So looking at the inner integral here, integrate this with respect to z. Remember, there's a 1 here. So when you integrate 1 with respect to z, you're going to get z from 0 to r squared. So now put r squared into here, and then take away, put 0 into here. That will then give you r squared, but then you've got this r here. So that will then give us r to the power 3. Remember this r here. So that r there is this r here, which, well, when you put this into here, you're going to get r squared, and then you've got this r here, so that will give you r to the power 3. So we are now currently here. And then integrate it with respect to r. So that will give you r to the power 4 over 4 from 0 to a radius of 2, from 0 to the radius of 2. So now put 2 into here. That will then give you 4. Put 0 into here, it will be 0. Well, overall it will give you 4. And then integrate it with respect to theta. That will give you 4 theta from 0 to 2 pi, and then that equals 8 pi. So the volume is 8 pi. So now let's check it with our traditional single variable calculus. So the volume, our volume is given by the cylinder. Take away this volume here. So using traditional calculus, this has a radius of 2, and then it has a height of 4. So the volume of the cylinder is this thing here. And then set up single variable calculus. So you're moving along like this. remember this is y equals x squared, so x, this length here, this x length is root y. Remember, I'm rushing through this. I'm expecting you to know this by now. This is single variable calculus. So that would be this distance here. This distance here, the x distance, is this thing here. Quickly pi r square it. So that would be, this is our, well, set it up. So revolve it 360 around here. So that would be pi r squared from 0, because you're doing it from a height of 0. Hang on, you're doing it from a height of 0 to a height of 4. You're doing it from a height of 0 to a height of 4, and then this would be dy, and then this whole thing here, well, a constant, take it out, that will then give you this. Integrate the y, that will then give you this. So it's blah 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 blah. We've done this many times before. It also gives you 8 pi. Okay, so the volume is 8 pi.